Great.
So, hi, folks. Good morning, good afternoon, good evening from whichever part of the world you are. Because right now I'm with Abhijit Chatterjee, sir, telling myself that knowledge of what this Azure Kubernetes cluster is also all about. It's not about basically Azure Kubernetes cluster. It's also about like how we can really get to know what this technology is also all about. So, right
Right.
now, this technology is in a lot and lot of market space because this is what technologists are more focused on. So right now we are with Azure developer community. This event is being hosted on this, and right now we are conducting a lot of events, and you can see it in the upcoming events as well. So there are a lot of events lined up, and Azure developer community Bangalore is also coming up with lot of events. So hop in to our community, and there's a catch here. So right now, when you just go back here to our portal, there's a join now, become an organizer, sign up as a speaker. So there's a lot of chance that we are giving to you. So make sure that you use it to the complete extent and make sure that you come out as the best engineer of what you have ever dreamt about. So I hand over the session to Abhijit Chatterjee, sir, so that you all can get an access to the knowledge of what this technology is. So I welcome Abhijit, sir.
Thank you. Namaste, everyone. So, I am Avijit. I am also an infrastructure software engineer, and I'm also founder of the Kubernetes Pedia. And I built a number of tools like Inlight app. It's an analytical app for the social media. And I also built the Hacker Street, which is a office rental platform for B2B clients. And I also worked with few of the consumer startups like Mbibe at Pushup. And there's so many companies are also there that I am consulting with. Let's start from here. So in this session, we'll be going through the AKS cluster, how you can easily set up an AKS cluster, and what is Kubernetes actually is. So what is a Kubernetes? So I think you already know that Kubernetes is a very it's a talk, like everyone is talking about Kubernetes, everyone is talking about containerization, and but within a very short span of time, it is almost every companies are adopting Kubernetes as their orchestrator platform. But what Kubernetes is actually? So as I said, it's an open source platform to manage the containerized workload and services. So you know that that's an open source code base that you install in your platform. It can be AKS, it can be EKS, or it can be GKE, any platform. Or if you are also having your IDC like any other data center, there also you can install the Kubernetes. So this is a platform independent solution. You just need to have the hardware to install that particular software. So there is a two parts in the Kubernetes. One is the master, another one is the node. In that master, we call it control plane. So now, what is master and node? These are nothing but the VM, the virtual machines, or the hardware where you are hosting your applications, right? Let's say you are running an Python application, but you are hosting that application somewhere. So you need a server. So that's the server is the thing where we are storing the Kubernetes code base, the Kubernetes master, and Kubernetes node. Now, in the control plane, there are a lot of other dependencies in the control plane, like how Kubernetes manage the control plane. Uh, like in the next slide, I will tell it. So it has a lot of other parts like API server, then it comes cloud control manager. So this is optional. If you're using any cloud platform, then it will be a part of your cluster. Then the control manager, then the etcd. So Kubernetes has to store the data somewhere, right? Like whenever you are deploying something, you are making some configuration changes, you are adding a deployment, but it has to store it somewhere. So that's why it is using etcd persistent store, and that etcd is a config store management, not a database, but you can think of it as a storage where we kind of use it to store the config. And then comes Cubelet, and then kubeproxy, then scheduler. So it is all part of the control plane. Now comes to the node. node is where your application will be hosted. So in the control plane, Kubernetes master node will be there. All the Kubernetes component to make the cluster up and running. And node is something which is also a VM, but where you will be hosting your own application for your let's say Java, Python, or any Node.js applications or any language. And each of the node is having kube proxy and kubelet. In our next slide, we'll talk about this in brief. So first, let's say that what is control plane. So in the control plane, I told you that we have a kube API server, right? So what is good thing about Kubernetes is Kubernetes has a API. And if you just use that API, it will give you the health of the cluster, not just the health, it will return the response in JSON format, and which tells a lot about the cluster. Like what are the running pods, what are the pods are in pending, and how many deployments are there, what is the config map. Like it's a kind of API server where you can make the call to the Kubernetes API server, and in return it will give you the JSON response. Then comes the etcd, which stores the cluster data. Like whatever config changes you are doing, whatever deployment you have, like it has to memorize, right? It has to store it somewhere. Because today you are going to deploy your Python application, you are running some deployment script, you are adding some storage to it. But if Kubernetes doesn't remember, if it removes those data, if you come tomorrow, you'll not be able to find out whatever you have done yesterday, right? So that is why it is storing it in the etcd storage, so which is a config store, and where Kubernetes is storing the data. And then the kube scheduler. So that the work for the kube scheduler is that it makes sure that all the pods, like each of the Kubernetes will have the container and pods, right? So kube scheduler makes sure that each of the pod is having some node to be assigned. Because when you're deploying something, let's say today you are having 5 microservices running, and each of the microservices having 2 pods, and so there are 10 pods, right? Now tomorrow you come up with 2 more microservices, which will occupy, let's say 4 or 5 more pods. But when a new pod is coming, right, it has to scale the nodes also, right? Like if the node is full, then it will create another node, or if node has available space like CPU, memory, whatever requested resources, then it will try to fit that pod inside of that node. But the main fundamental thing is that every pod should get assigned to a node. So that is the job of the kube scheduler, which makes sure that every pod gets a node. And then the cloud controller manager, so it has some cloud specific logic. Like if you're using Azure, then it will have the AKS specific logic, and so on for other cloud platforms as well. And as I said, that control plane is the heart of the cluster, and whatever changes you are doing, whatever the health of the cluster and how the cluster will perform, that everything gets decided by the control plane. And it also makes sure that it belongs to a high availability zone. So if one node goes down, your cluster should be up and running. If you're using managed services, then it gets to managed by the cloud provider. Or if you're having the IDC setup, you have to manage a multi-master HA kind of setup. And then we have kube controller manager, which is like all the processes, like whatever control process compiled into a single binary and run as a single processes, right? So in the master, there will be multiple processes, like to make job 1, to make job B, to make, like there will be like job A to C, there will be around 4 to 5 jobs, and for each of the processes there will be logics or anything, like you understand, like for Kubernetes, it's like you will have the multi-cluster, like lot of nodes will be there, lot of pods will be running. So kube controller manager process is compiled into a single binary and then run it in as a single process. Next, we are talking about node. Now we just discussed about what is control plane. Next, we are going to discuss about what is node. So before going into node, let me talk about pod and container. So pod is just a set of running containers in the cluster. So what is container? Container is like uh, just assume it as a Docker container, like you are running some Docker file and then you are running a Docker container. In that container is something where your own code base is hosted. For your, let's say you are building some Python or Django code, so that container will hold that Django code base. Now each pod can have one or multiple container, so that is based on your requirement. Like whenever you are deploying something in the deployment file itself, you can specify that that one pod should have how many containers. And most of the cases we can have, or one pod can have one container. Also, if you are having any sidecar container, in that case one pod will have multiple containers. Now, as I said, node is something which is a single VM and which runs the containerized applications. And in the Kubernetes, most of the time you will have the multiple nodes, because you are choosing Kubernetes because of the high scalability, and it should scale automatically. So whenever some load is coming, it will scale automatically and it will spin up more nodes, and accordingly more pods will get assigned to the new nodes. And then the kubelet. So kubelet and kubeproxy are two very, very vital points in a node. That kubelet makes sure that containers are running in a pod. So you have a Docker image, but you are also having some pod, right? Now a pod needs to contains the container, and whatever applications that you are writing, it should go live, right? So there should be some method or process which makes sure that each of the pods are having some running container. So that is the work of the kubelet, which actually makes sure that containers are running in a pod. And then the kubeproxy. So kubeproxy is a network proxy, and which is responsible for network operations. Like if you're making a call from the one service to another service, if your let's say you are building some registration system, so you will have a sign up, you will have sign in, then you will have user profile, and three microservices needs to talk to each other, right? So this is why the kubeproxy is coming, which is actually responsible for all the network traffic, network operations, so that each of the pod can talk to outside of the world, or each of the pod can communicate within themselves. And then container runtime is it is actually make sure that all the containers are in running stage, and it is actually the responsibility of container runtime is for the running containers. Like if any container goes to the crash loop backup, it will try to make the container restart or make the container running. Okay, so we discussed about the basic of Kubernetes. Now what I did is I have my own Azure account. You can see it here. Let me just refresh the page. I already have a like Azure account, and I created from my ID. And you see that I don't have any Kubernetes services specified here. So in this session, I will be writing a Terraform script which will actually create a Kubernetes cluster, and we will be running some pods inside of it. So I have already written the script. You can find it to the Kubernetespedia GitHub page. You can go to github.com/kubernetespedia/AKS Terraform. Here you'll be getting all the files. It is also contains a README file, main.tf, output, and variables. So let me just go through and check what is there inside the KS Terraform. Let me first open main.tf. Sorry. So in the Terraform, first we are defining the provider. So in our provider, this is Azure RM. And we are also having the subscription ID, client secret, and tenant ID. So this is a Jumpbox VM, Azure virtual machine, that I created to deploy this cluster. You can also have a similar setup. And once you make the VM ready, once you log in, you have to set up the Azure CLI. So when you set up the Azure CLI, you can find a guide in the Azure Microsoft Microsoft Azure support. And whenever you are going to set up the Azure CLI, you will have the subscription ID, client ID, and client secret. And don't share it with anyone, because this is very secret credentials for your cluster. And that is the reason that I will not be showing how to set up the Azure CLI. But I had set up the Azure CLI, and all the variables like client ID, secret, tenant ID, or subscription ID, I have it in the variable file. Then I am going to create a resource group, and I am also maintaining a variable file where I am writing the resource name and then the location, in which location I want to spin up the resources. And next I am going to set up a VNet. The name of the VNet is the AKS VNet. I have hard coded the name here, but you can also set up a variable in the variables.tf, and you can keep the name there. And then it's very simple. I am also creating a subnet, and then comes to set up the Kubernetes cluster. In that Kubernetes cluster, I am creating a default node pool, and in that default node pool, so I am uh, enabling the auto scaling of the node. And so auto scaling of the node, why we want to enable is that let's say right now you are having only one pod, right? One pod, yeah, one node will be enough for a pod to be running. But tomorrow you are having some 3 or 4 other microservices, and in that case number of pods will be higher. Now if you mention, if your requested CPU is higher than the CPU or memory allocated to that particular node, that so the new pod will not be able to initialize, or the new containers will not be running, because it requires another node to be spin up, right? So that is why we are using the auto scaling. So in that auto scaling, it will have minimum node is 2, and the maximum count is 5. So it will, whenever you deploy the cluster, will have a minimum node of 2 VM, and it can go up to the 5. So at least it will make sure that you are not running out of resources at any given time, right? Whenever your pod needs another node to be to get assigned, it will spin up another node, and the maximum value is 5. And then the network profile, we are using Azure CNI. You can use the Kubelet, but I will prefer you to go with the Azure CNI as a network plugin. And then the network policy, we're using Calico, and the load balancer SQ, this is a standard. You can have the premium also, but in our example, we are having the standard load balancer. Then it's simple. So this is a service principle where you want to add client ID and client secret. So that client ID and client secret you will get to know while doing the Azure CLI setup. It will be showing in the output. Now I am also showing the output file. So in the output file, we want to get the client certificate, then the kube config, and then the FQDN of our cluster. But I kept it as a sensitive true because I am doing the session live and I don't want to share the secret credentials to the audience. So that's why I kept it sensitive true. But you can remove that, and in the output it will show you the client certificate, kube config, and what is the FQDN. Okay. And then we have the variables.tf. In that variables.tf also we are having the like if you check the main, whatever variables we are having, like cluster name, and then comes the DNS prefix, then the agent node, and then the client ID, client secret. So those variables name I have assigned into the, I have declared them into the variable.tf. Now I have also installed the Terraform here, and if you want to run the Terraform code, you can do Terraform apply. You say before doing the yes, let's say that what are the things this Terraform is going to speed up. So it will give you a list of all the items it will going to spin. So in our case, we are having the cluster name Kubernetes AKS 1, and the location will be East US. And then all the policies, Azure policy, it is also showing network profile. It is also showing PM size. We are having standard D2 V2, and then it is also showing the minimum count is 2 and the node count is will 2, because in our node setup, while adding the default node, we have kept it as a 2 as the minimum node. That's why cluster is starting with a 2 node. Sorry. So once you are done done of checking of all the things, if you see that everything is right and it's good to go, you can just type yes here. Now it will start creating the cluster. It will take some time to create the cluster. In the meantime, I will let me refresh the page and see if it is coming here. Okay, it's not coming here yet. Okay. So in the meantime, let's talk about how you can secure your cluster, right? That's a very interesting thing here. Like, you know that your cluster is having the Kubernetes or Kube server, Kube API server, correct? But most of the cases, like whatever security breach happened, whatever hack happened, most of the cases what happens is this Kube API server is open to the outside of the world. And why it is very much insecure, why it is very much important to keep this Kube API server limited to your cluster only, because it is having all your cluster data. You can just make a post request, Kube API server will give you the data. You can also make the changes in your cluster. You can remove a pod, you can delete a node, or anything. Like, you can create your malicious container to be running inside the cluster if you have the access to the Kube API server. So it is always recommended not to make the Kube API server endpoint public. Keep it only private, so that only you or your organization can access to this, but not anyone from the outside of the world. Now, when you are setting up the node, sometimes what happens is like, if you're having a managed Kubernetes cluster, this is fine. Most of the time, AKS will get it updated, or it will give you the recommendations, or it will give you the warning that your cluster is running. It's running a very older version, and you need to upgrade it if there is any security patch. But as a good practice, you should never ignore all those recommendations and security patches that Azure is giving you. Sometimes what happens is probably the ways you are having the node that is very outdated, and it has some CV register, right? And some attacker can do a RC attack, or anything. That node can get compromised. If that node can get compromised, the attacker will have access to all your containers or applications, right? In that case, your application will stop working as well. So it is always recommended to follow the Azure security recommendations or Azure security patches, and keep your cluster up to date, even if not very latest, at least one version down. At least try to make sure that your cluster is one version of the cluster is one version down, one latest version down. And another thing is that this pods, the Docker is not like this container. Like, when the container is running, this kernel is not a dedicated kernel. It is sharing the kernel to the host. So the Docker container, or the pod that will have the containers should never have the root of profile. So while making the Docker file, you should create a user, and you should give the specific permission to those user to that Docker file. Some of the cases, like I have noticed in multiple organizations, they are running the Docker as a root, but that's never a good practice. And whenever you are deploying something in the cluster, make sure you're properly scanning the images, and don't just randomly deploy anything from the internet. So most of the things what happens, let's say you are going to deploy some other mm, infra related code, right? Let's say some monitoring tool or some scheduler or something which looks like that it will help you to enhance the operations in the cluster, but but you are downloading it from the any public image repository, but you are not properly scanning it. So it is also, when the container is running, that it is also sharing the node with your applications running there, right? So it can perform some attack, perform some brute force, or it can do some security testing by sitting inside of your cluster, which can affect your business or other containers are running inside of it. So it is always recommended that you perform a security scan of any public image before deploying it in the cluster. Now, another thing is that you're maintaining all the security policies. Your cluster is pretty much secure. Your Kubernetes API server is not public. You're upgrading your cluster. Your nodes are very, very much upgraded, and your whatever containers are also running. That is also like you are doing this thoroughly security checks and before deploying anything in the cluster. But still, there's some possibility that you are missing something. So you should always keep in mind that there will be some possibilities that you are missing something. So you should maintain a security logging platform which will have all the logs of your cluster in a dashboard, or you can consider ELK stack, which will which will contain all the incoming and outgoing requests. And you can have a dedicated teams looking at the dashboard, which will tell you like what are the requests coming inside the cluster, what is the parameter, if any request is looks like the skill injection or not. So you can have a dedicated ELK platform or any other tech stack you can use, which will have a security logs, and that will work as a security data lake. Okay, let's back to our cluster and see if it is ready. Okay, that's great. It is ready. We can see that it is saying apply complete, and this is the output. This output is not showing here because I have added the I have declared them as a sensitive true, right? That's why it's not showing. Now we'll go to the Azure portal and see our cluster there. Let me refresh the page. Oh, sorry. You see our cluster is there. I can click on the cluster. You can see the network type plugin is the Azure CNI because I have added the Azure CNI in the policy. You can check it in the main.tf. Let me show you again. Here, I want to use the network plugin is the Azure, right? That's why it is taking the Azure CNI. Next, I will also show you, the network policy. It is showing the Calico, right? So I am also having the network policies Calico, and then load balancer, it is showing standard. I am also having the load balancer SQ is standard. And Kubernetes version, I didn't specify any, and it took the latest version. And the node pool, I have created one node pool, default node pool, and it is having only one node pool. At the node sizes, it is saying standard D2 V2. I think we have specified the D2 V2 only. It's not showing here. I have added it in the variable file. Yeah. So var.size, in the size variable, I have declared the node size as a standard D2 V2. And let's say the node pool. Okay, let's click on the node pool. Yeah, here you are having one node pool, the name of the default. You can have any other name also. I have mentioned the name is equal to default. That's why it is showing the default. And the node size is D2 V2. And let's click on the node pool. And it is having that two node because in our case, the minimum requirement was 2. So it is having 2 node, and the availability zone is 1 and 2 because we have specified 2 availability zones, and we also have the autoscaling enabled. because yeah, here you can see the autoscaling enable because we have specified the enable autoscaling equal to true. Now you can see the nodes from here. You can see that 2 nodes are running. Both of them are Ubuntu images. Let's go here and I'll show you the VNet setup that we did. Yeah, so virtual network, it is checking the AKS VNet, and that VNet we also created while building the cluster. You can see it here. Here you can see this is the name of the VNet, AKS VNet, and we also created a subnet which is AKS subnet. Here you can see that AKS subnet, and here also we have the AKS subnet. And the cluster that we launched it into the AKS VNet. So if you just check here, location is fine. If you just check it here, yeah, the default node pool, if you just check the node pool, the VNet subnet ID, which is Azure RM underscore subnet dot k8s dot id, right? What does it mean? So Azure RM underscore subnet is the resource k8s. Inside the k8s, it will take the ID. So ID of the AKS subnet, which is uh, which starting with a CIDR range 10.1.0.0/22. So this node pool will have the subnet, AKS subnet, and this AKS subnet is part of the AKS VNet. Here we have mentioning Azure RM virtual network dot k8s dot name. If you check it here, we have Azure RM virtual network and then the k8s, Azure RM virtual network, then dot k8s. So it comes into the k8s, then dot name. Name we are declaring here, which is AKS VNet. So that is how this node pool is getting created inside AKS VNet with the AKS subnet. If you want to check the VNet also, you can check it here. You can click on the VNet. It will give you all the instances, connect all the connected device, and then it will also give you the address space. That address space you mentioned in the Terraform. This you can see this CIDR range. Yeah, this is exact same, and the location is US East. I want to deploy it in the US East. There is nothing. You can go back to the subnet. Yeah, if you check on the address subnet, right here you can see the sub address space, which is also starting with 10.1.0.0/16, and it is having 65536 addresses. This is the address space, sorry. Yeah, and if you click on the subnet, here you will see the AKS subnet, and which is having 957 available IPs, and the AKS subnet is this subnet. Okay, let's go back to Kubernetes cluster. Now, how to access the Kubernetes cluster? I have already installed the kubectl, a command line utilities that will help you to connect to the cluster. I can connect from here. Yeah, let me run this. Okay. I have installed it, I think. Let me install it. I think I missed it. We want to install it for the Linux. Okay, you can just run these commands blindly. It will work. We need to make sure the checksum, and we'll verify the checksum. Yeah, that's verified. And then we'll install the kubectl. It's done. It's no pod. Yeah, so in the default namespace, we don't have any pods running. If you want to check it inside of the cluster, that also you can do. You can go to the workload from the UI. If you want to check, it will give you all the so it will give you all the deployments are running inside of that Kubernetes and Kubernetes cluster inside of that AKS cluster, and all the deployments that you were seeing here. So they belongs to the namespace, and these are deployed by default. Like it comes by default with the Kubernetes. This is not something that you deployed. That you can check by using this command. So what I did is I did kubectl get pods -n kubesystem -n to specify the namespace. If you do this, if you check it here, core DNS, it is showing the namespace is cube system, right? So we are inside the cube system namespace, and we want to check what are the pods deployed in the cube system namespace. Similarly, if you want to check the deployment, you can check it from here. It will give you all the deployment. Now all the pods are a part of the deployment. Like deployment is a config, and pods are the one which has the running containers, right? So this core DNS deployment is responsible for the core DNS to be running. And similarly, we have the matrix server deployment. So you can have only one deployment. In that deployment only, you can specify that how many replicas you want. So that will create that number of pods in the cluster. So pods is something which is holding your store, holding your like inside of which is a which is responsible for schedule, like, right? So in that deployment, you make sure that you are having the correct config of your pod, correct image, and the resource utilizations, request resource, or let's say your application needs 2 GB of RAM and 1 CPU. So that also you deploy in the deployment. Sorry, you mentioned in the deployment. So deployment is a config, and which actually in result which actually creates the pods, and that inside that pods you can have one or multiple containers, and the container is your code where your Java, Python, or Golang or any other codes are running. Okay, fine. We can also create the namespaces to check what are the namespaces we have. So by default, we have the default namespace, kube node release, kube public, and kube system. These 4 namespaces will come by default. Now, another thing is that we want to deploy the, let me go to the deployments folder. Here I have a file ingress nginx. So we want to deploy the ingress nginx. So ingress controller will have the nginx images. So that we want to deploy because we want to make a communication to the cluster from outside of the world. Like we want to make some we want to make some request to the nginx, and this nginx can forward the request to your respective pod. So that's why you want to deploy the ingress nginx. The deployment file I already have. You will find all those files in the GitHub. So to apply it, let me just apply it like that. You can write any YAML file and you can apply them using kubectl. So that is ready. And inside of, if you just check the output, you will see that namespace ingress nginx created, right? So I want to deploy this ingress nginx inside the ingress nginx namespace. So I have created one more namespace. So if you check the YAML file here, if you go up, a little more. We are almost here. Let me search by namespace. Let me search by. Just cat it so that you can check. Yeah, here you can see that. So in this file, first I'm creating a namespace called ingress nginx, and whatever resources I'm going to create, I am mentioning the namespace as ingress nginx. So this ingress nginx will be deployed inside the ingress nginx namespace. So if you want to cross check, you can do a kubectl get pods -n ingress nginx. It will give you all the pods running there. We are right now we are having only one pods to be running, which is ingress nginx controller, some random string. And if you want to check the deployment also, that also you can check. Yeah, we are having only one deployment. In that deployment, let me show you what is there inside the deployment file. So you will get to know that how we are spinning up the pods. Yeah, here if we just go a little below. Here you can say that as specifications, we are having only one replica. So that's why there is only one pod is running of that deployment. And we are also having the images here. I'll show you. Sorry. Yeah, here. So here we have the image ingress nginx controller v0.44.0. You can also have the liveness and readiness probe to be there. And this file is already there in the Kubernetespedia GitHub link. You can download and run this file. And if you see that your ingress nginx needs more memory or CPU, you can modify that value. So in our case, I am using 100 CPU and 90 MI memory. You can modify that value, and then you can do a kubectl apply. Now I will show you the Kubernetes service. Yes, it will not give you, if you just hit this clustered IP from your internal network, it should open the nginx ingress like default nginx page, but it will not work from here because the VM that we have, it is in a different VNet, and that Kubernetes cluster that we have, that's a different VNet, right? So we don't have the pairing inbuilt. So if we have the pairing, then you can call that this load balancer from there. I'll show you. Let me, if I go inside a pod, I should be saying it. I will try to see if we have curl install in this ingress nginx, then I can show you. This is how you can go inside of a pod to check if you want to debug something. This is how you can go inside a pod. So you are going inside the ingress nginx controller pod. Yeah, we have the curl. Yes. So here you say that why it was not working from my VM, because this jumpbox VM, right? This jumpbox VM is in a different VNet, but the cluster that we created, Kubernetes AKS one, that is in a different VNet. Now we don't have the peering in between. That is no connectivity is there. That's why when we did a curl, it didn't work. So what I did is I went inside of the pod, which is ingress nginx, and from there I am doing a curl, which is this. now it is giving me the Nginx 404 default page. Like, so if you have the peering in between, then you can open it in your like in this VM also. And like if you want to connect it from a load balancer, then also you can create a load balancer in that particular VNet. Like you can create an application gateway, and in the application gateway you can give that IP address. Now we also have the public IP address. Let me see if it works. Yeah, it also works at public IP address. So if you want to check it publicly, I will check it in my browser. So it is working, right? In my browser, when I did this hit, it is opening the 404 page of the Nginx default page, correct? Now I will also check the logs. So what is happening is this deployment, like Ingress Nginx, it also created a service. Now I'll show you the service config, so it will be clear for you. You can edit the service like that. And whatever we do, we have to specify a namespace, otherwise it will take the default namespace. Since we are using Ingress Nginx, that's why I'm using -n Ingress Nginx. Here, if you check in the service specification, we have selector, right? So this selector is having the name called kubernetes.io/component controller, and then the instance, then the name. So what is the meaning of that is, if you try to hit that service, it will try to find the controller with those tag. Now the pods that we have, which is running inside the Ingress Nginx, it is having all those tag. So that is how the service is connecting to the pod. If you want to cross check, you can do it here. Like this is our pod, right? You can do a kubectl describe pod. It will give the details of the pod. Press Nginx. Here you see the label. So just remind yourself that we just checked a few minutes ago that this service is having the selector with all the names, like this name, this instance component, and then the name, right? And if when I check the pod also, like when I did a describe pod, it is also having those labels. So that service, Ingress Nginx controller service, is forwarding the request to this pod. Not only this pod, if we make the deployment replica set 2, then it will have the multiple pods, right? So so basically this, if we hit that service, this service will forward the request to the pods which is having the label of this level, like whatever labels you mentioned in the service config. So while creating this service, we are also having a private endpoint and one external IP endpoint. So if you check the if you hit the external IP, when in my browser I am hitting this external IP, the request is coming to the pod. Request is actually coming to this pod, right? So you know the Nginx, if you don't specify any domain or path, it will give you the 404 page. So this is what is happening here. I didn't specify any domain. I'm not opening with any domain, right? So that is why it is giving me the 404 default Nginx page. If you want to check the logs to be sure, you can do it here by here. kubectl logs -f -n ingress Nginx. Let me do a kubepod. Okay, so I'll tell you that why it is not showing here, because yeah, it is not showing because we have the logs of the Nginx log we are having, right? But we don't have the log of the request log. It's not enabled. That's why it's not showing. Like whatever request we want to make, if we want to get a string, any other string, it should show in the pods. Why it is not showing is because we don't have the request logs enabled in our deployment. So that is why it is giving the logs of the pod, not the request that we are making. But whenever we are hitting this public endpoint, it is going inside the ingress nginx pods only. Now, if you want to check it from the UI, you can do it from here. So let me refresh the page. You can go here, you can do namespace. Now you can see that we are having one more namespace, which is ingress nginx, and we just created 13 minutes ago. So this is the namespace that we created. Now you can go to the workload, and in the workload also, yeah, ingress nginx controller. You can see this is the one that we created, and we don't have any service we have. It should show the service also. So yeah, it is giving the service endpoint also, ingress nginx, which the namespace is ingress nginx namespace. Then comes the insight. We need to enable the log analytics workspace, because this is where the Azure will push the log. You can see that you can use the Azure Insight to check your pod statistics, like what is the stage of your pod, like any other, if it is running out of resources, or if it is running in crash loop backup, or any if it is in pending state, you can use the Azure Insight to check it. We have metrics also. You can click on the metrics. Let's say CPU node, CPU uses, average CPU uses. So you can see this is very less, because scope is the Kubernetes AKS, right? Because we don't have any other cluster at this moment. We only have Kubernetes AKS one. That's why it is showing. Then the matrix namespace, we are having the container service and the CPU. We are checking the node CPU. If you just click here, it will show you namespace this matrix CPU in millicore, right? Right now it will not be much, because we are having only one or two deployments are running. You can check the logs also if you want. I think we are already enabling that. Let's wait for a few minutes. And one more thing to mention here is that you can see that I mentioned the network profile. Yeah, this is not mandatory. You can remove the network profile, but if you remove the network profile, it will take the default setup, and which is a kubenet, and it will also not having any load balancer or network policy. Calico, right? Here you can specify, but there it will take a default setup, right? So I have seen a lot of issues while using the kubenet. So it is always better that you use the Azure CNI as your network plugin, and that is also recommended by AKS as well. Let me refresh it. There will be no data. So you can click on the inside, then it will give you the columns where you can see the data of the cluster or the node. It will not give you any data because the cluster we created, it's just a few minutes ago, right? So right now it will not give you any data, but you can enable a log analytics workspace where it will store all the logs, and you can go to the inside to check the uh, stats of your deployment. Like you can click here, deployment preview. I want to see the statistics of my code DNS logs. Let me click on the code DNS. It is giving you here it is actually raw data. Let me see the raw data. Okay, that's great. So if you click on the deployment, right, in that deployment it will give you all the deployments that you have in the cluster. You can come to here by clicking on the inside under monitoring, and then you can click on the code DNS. Now in the code DNS, so this is something if you want to have a flexibility in the UI, like you don't know, or probably while debugging you want to see that what is the deployment. There are two things. One is you can always do it by using kubectl, or if you don't want to use that, if you want a UI to do that, you can do it from here. You can use the inside under monitoring, then you can click on the deployment, and in the deployment it will give you all the descriptions of the deployment, like what are the selectors it has and how many replicas it has. It will say that it is having 2 desired and 2 updated. Two total, 2 replicas is there. 2 desired means while making the deployment we have specified that this deployment should have a 2 replica, and that is what is happening. Total 2 replicas are running. So in case sometimes what we'll see is that we mention 5 replicas for any deployment, right? Or probably 2 of them are running and other 3 of them either in pending state or the crash loop backup. So that time something is wrong in the cluster. You need to actively check on the logs that what is happening, why these pods are not running. Uh, yeah, so this is something where you can quickly check and see what is the statistics or what is the stats or stage of your deployment. And the containers log, it is not showing here because this is a very new cluster. If you run it for, yeah, it started showing now. Yeah, so let me show the average. It's not to do this. So this is the container, like all the containers are running. You will see our ingress nginx control. Yeah, pod is also here. Here, I think. Let me search.
Sir, I think you can hide that. Hide that. It would be like easy for
Yes,
you.
yes. So right now it is showing the matrix of the default containers, which is there inside the AKS. But I think if you just run it, keep it for another 1 hour or 2 hours, then it will be showing the ingress nginx that we just deployed. So it takes some time to collect the data. So here you can see like what is the name of the container and what is the average utilization. Or if you want to see the something, let me check the memory working set. Yeah, it will also give you the memory working set, and here you can see the pod name also, and this pod is scheduled to this node, so you can check it from here. And also you can click on the workload. In that workload you can go in the ingress nginx. Here also you can check on the live logs. It will take some time, but it will show here. So this is not showing because it's a very new cluster. But if you're having active cluster where log of like lot of requests are coming, then you can see the stream also. Like it, whatever request is coming, it will show all the logs here. Or if you want to make some changes in the YAML file, that also you can do. Here you can have all the YAML file that we just created. Let's say you want to change it here, right? uh, Termination grace period, let's say you want to do it 600, you can make it 600 and then you can the review and save. That also you can do. Or if you check on the overview, in the overview it will show you the pod, which pod is running. So this is the only one pod is running inside that deployment. That is what it is showing. And restart count is 0, so this pod is healthy. So in case of like some of the times you will see that restart is like 100 times restart or 5 times restart, so that means your pod is having some issue. You should check on the log to debug the what is the problem in your log. You can also see the pod IP. So this is a virtual IP get assigned to each of the pods. And it will also show you the node. Like node is a virtual machine, so this pod is registered to this node, like gets assigned to this particular node. Insights. Yeah, so if you click on the insight, it will give you the name of the pod and then the status of the pod. So we are having only one pod, that's why it is giving only one pod. Otherwise it will be showing the multiple pods. And the CPU uses last 6 hours is 0% because, and memory uses is 2% because these pods are very new. You can click here to get into this description. So this pod will also have, if you just click here, yes, yeah, let me just do it. So if you click on this deployment, right, it will give you the insight. So in the deployment, we have one replica set right now. In that replica set, inside of the replica set, we have only one pod, and in that pod, we have only one container. Sorry. So it will give you the tree also, like first is replica set, then the pod, then the container. Azure also have log analytics. You can check it in the log analytics. This is a managed service by the Azure. Yeah, in that log analytics also, if you want to check the logs of the pod, that also you can do. You can write the queries here, you can set the queries here, and then you can run, and it will give you the like in our case, it is giving the controller name, then the kind of a controller, then the pod status. So these are the jobs, and that the jobs status is succeeded, and this is the replica set where status is running. So this is all about the insights of the AKS cluster. Now, once you are done with everything, if you want to shut it down, then what good thing is using Terraform is you can just do Terraform destroy. It will actually destroy all the things like this Kubernetes cluster or the VNet or subnet, whatever you created. So that's it for this session. I think you all liked it. Just give me in comment, just in the feedback, you can give me the feedback, or you can connect me on the LinkedIn if you have any questions, or you can write it the comment also. I will be glad to reply.
Sure.
Or
I
you
think
can check the GitHub also, Kubernetespedia. I push a lot of information code base here. You can just keep watching it, and all the code that I used, you can find it on the GitHub. Or if you have any question, you can
you can
directly ping me also.
put that online on the private chat. I'll put it in the comment section.
Yeah, you can do that.
Sure, this Terraform. Guys, this is the one which will be going to use. So you guys can go there and you guys can see what's happening. Lot of question from Gyanraj and Indrajit Kumaras. And these two are the people who have really asked all the questions. I think probably others are like we are having the same question. So
Yeah.
Gyanraj is asking, what is ingress? What is the use in application?
So, so let's assume you are building a application, right? One logging system or one registration system. Ingress is something which will like inside the Kubernetes node knows that what are the pods are running. But as a user, like I will be the user in your cluster. I need to interact with your cluster, right? I need to make my request to your pod, or your application should have a business outcome. So that's why we use the ingress. So ingress controller is a Kubernetes component for the routing, and it helps you to reach the pod, and it also gives you a endpoint by which you can connect to a pod. Now you can use the default ingress by providing by Kubernetes, or you can also have the ingress Nginx. In our case, we are using the Nginx one.
And also, Gyanraj is asking how to debug the pod if the pod is not running due to some issue.
You can do it by using the Azure Inside also, or I have shown you that you can do the logs by here, kubectl get pods -n. It will give you all the logs. You can select the logs from, you can select the pod from here. It will give you the logs of this pod. And if the pod is not in running stage, or if it is in pending state, you can also do describe pod -n ingress nginx. So it will also give you the description. It will not give you the log, but it will give you the description. Like in the description, you can see what are the steps. First, it assigned to a node. Here you can see first it assigned to a node. Then it got a volume. Like it failed, but it will keep trying it until it gets succeeded. And then it pulled the image, and then it created the container, then started the container. Now the Nginx is running successfully. So these are the two things you can check by using the kubectl, or you can also go to the Azure Insight to check the same.
Sure. What did Helm? Why did you use Helm and Nginx application?
Helm I didn't use. I am running it using the YAML file. So you can also Helm use, but in our case, it's a simple YAML file that I used, and I'm applying using kubectl YAML. Kubectl apply. It's not a Helm deployment.
All right, and also, uh, what is the use of the readiness and liveness in the application?
Correct. So what happens is sometimes liveness is like that is the like you are running some container, right? So in that container, let's say you are running some Java application. So that Java application will take a 1 second or 2 second time to boot up, right? In that case, so until and unless it has a liveliness and readiness probe, or like you are restricting the outside request to come inside the cluster. Like it will wait for that time. First is it will wait for 30 second or 40 second for this container to become live, and then it will wait for another 30 second to make it ready. So yeah, so what happens is probably your container is not running, but your pod is showing, pod knows that okay, this container is already in running state, but you know that your application actually takes 4 or 5 seconds before it comes in the running state. So you don't want to make the request come inside of your container, right? So in that case, you assign some readiness or liveliness probe, which tells the Kubernetes that you wait for 30 seconds or 5 seconds before making any request to the cluster, like to that specific container.
All right, yeah, that's actually true. In order to get all the application up and running. So the next question from Gyanraj is like how to debug a pod if pod is not running due to some issue because it was running pod before it was running pod. Like how to debug pod if the pod is not running due to some issues before.
Yeah, so in that case, what will happen is, like I'm assuming the use case is that your pod was in running state, but later it became a crash loop backup. So it can do a kubectl logs minus f, which will give you the like tail
Yes.
of the pods. Or if you also if you have the Azure Inside active, you can check based on the timestamp. You can check what is the last log you have, like what are the uh, so let's assume that you are having a database connection inside your pod, and then the database is not working. So your pod was in running state, but now it's unable to make a database connection. In that case, which is killing your Java process, and in result, your container is in crash loop backup. So in that case, also you can get it from the Azure Inside log. Or if you are having any other open source logging solutions like ELK, there also you can check based on the timestamp.
Yes. And Indrajit has asked about how can you make the Kubernetes stateful and stateless?
Uh, yeah, so stateful set is another kind. Like in our case, we are using kind deployment, and there also you can have a kind stateful set, which I didn't cover in this session. But stateful is something which will have its own. Uh, yeah, so first you have to understand that what is the difference between stateful set and the deployment. So all the deployments that that we are doing, these are stateless. Like you can delete a pod at any time. It doesn't need to worry about the data or storage. But in stateful set, you need to actually worry about the data or PVC volume. In that case, we use the stateful set. If we want to take care of the data or its own identity or its own state. But in our case, we are not using any stateful set. You can remove any container, a new container will come up. You don't have to worry about the data or the previous state of the containers. Or if you want to use the databases like Mongo or Postgres or any other database inside of the cluster, in that time you have to use the stateful set, because your data is important there, and you want to mount the volume to a particular pod only, because you want to connect using the service endpoint, right? So you should have a uh, pod to be connected to a specific PVC volume.
Yes. And Indrajit has again asked difference of pods, nodes, and containers in K8.
Yeah, so I said that pod is something which contains the containers, and container is your code. You can compare it as a Docker container, and the node is your VM where you are hosting your applications. A virtual machine, you can compare it with node.
Yes. And thank you all. GitHub link has been posted here. So you guys can go here and take a look at it. Actually, I think probably he's asking your GitHub link for the
Okay, you
session.
can.
For the session. I think probably you can share it later. I will put it in the
Yeah, I
comment
can
section,
share it
please.
later. Like this PPT, I don't have it in GitHub yet, but I will share it later.
Sure, sure. Yes, I think it was a good and informative session. It was a very short and an informative session. Thank you
Yeah,
so much,
yeah. There
folks.
are a
We
lot
are
of things,
glad.
but I had to finish it within an hour, so I just try to keep it as short as possible. Also, which gives you a good overview of the technical things.
Sure, I think this is great. Sir, thank you so much. It was a pleasure
Thank you,
in having
Vishwas.
you on the session. I think probably people are going to enjoy a lot of Kubernetes from now on. I think probably they'll not say Kubernetes is an headache from now on.
Yeah, right.
Thank you so much, sir. Thank you so much. Guys,
Thank
we are
you.
ending
Thanks,
the
everyone.
stream now. So if you have any doubts and queries after the session, do reach out to me or else reach out to sir for technical doubts so that we can clarify it. I'm not the speaker
Sure,
here, but
sure.
he is the one.
Sure.
So yes,
Thank you.
and if you guys want to be a speaker here, also do reach out to me here so that I'll give you a slot for being a speaker on these kind of sessions. So yeah, thank you so much, folks. Thank you so much.
Thank you, Vishash. Thank you, everyone.
Yes.